All right, so who had a good answer, do they feel, for describing early Earth and how photosynthesis really changed our atmosphere? Does someone have one they'd like to share? Go ahead, Vidit.
Early Earth did not have much oxygen in the atmosphere and did not have enough. However, due to photosynthesis, which was primarily from cyanobacteria, ozone layer formed, which allowed for life on the surface without contamination, and greatly increased the oxygen content as well to allow for land animals.
All right, good. So hold on. So early Earth had low oxygen, no ozone. However, because of photosynthesis, the oxygen content boomed. Photosynthesis, which was being done by, as you said, by cyanobacteria. The oxygen content boomed. This led to what? Leading to, well, not just land mammals. What does oxygen really allow for? Why? All right, leading to reactions that are, well, I'm going to go ahead and use oxidized by oxygen, which releases a lot of energy, right? So basically what this allows us to do, this helped for more complex organisms because oxygen releases energy and what I misspelled here? Yeah, I did. Releases energy and helps to fight entropy, leading to higher complexity, right? We'll see this in cellular respiration, aka oxidative phosphorylation. We haven't learned that yet, but that's what we are going to get to, okay? So hopefully you guys had some sort of answer that looks like this. Did anyone have anything they added to this or you felt like was important?
I think you hit all the major points.
Try to. Oxidize. All right, so hopefully those who are listening along. All right. Looking at the history of Bixen, explain what's happening, and if there is a drought, between these years, beak depth is at the bottom. So who was pleased with their answer that they had here? Riley, you really didn't like your answer? Okay, Quinn, show us.
So basically, what's happening here is like the deep depth is like getting a little like longer, right? So like the depth is like growing, and so like because the water's going lower, right? Because of the drought.
Yeah.
So it allows for them to get water from like higher up, I guess.
All right, is the beak depth increasing because of their access to water? Does anyone remember that Beak of the Finch movie? All right, so I saw two people say no. Jacob, you want to tell me no first? Why?
Well, because they need bigger beaks to break open food and get food, and then with the drought, it kind of kills off the smaller plants, leaves less food, easier to get for the smaller beaks, so they aren't able to get enough food and they die off. Whereas the birds with bigger beaks are able to survive and make food, and just the population.
So I'll tell you what I wrote, which is I think on there. So Quinn, that was a good idea that it was related to actually being able to access the water. But this does directly relate to the Beak of the Finch movie, which we watched a couple weeks ago when we read a little bit. So this is showing. Well, this shows that the beak depth increased from 1976 to 1978. The first thing you want to do anytime answering something like that is directly lead to the average, right, or to the data. This you could even want to say it increased from 8.8 on average to 9.8, right? This was happening because of the drought. So you go ahead and next answer, you answer what's happening. The drought impacted the seeds that were produced. This left only the thorny, hard-shelled seeds, larger seeds, that were, the larger beaked birds were more fit. So fit is a vocabulary word. I'm choosing that on purpose, right? Because it's talking about fitness, and able to survive and reproduce. Thus, the population changed, or the overall beak size looking longer. This demonstrates what? What's the trend that we would say this is demonstrating? Oops. Evolution by natural selection. There are different mechanisms that evolution take place, gene flow and genetic drift, and this is one of them. So hopefully that gets you into that answer. All right, choose the appropriate graph for this data set and add a caption. The large population of mice has been displaced and moved into the open space on campus. The mice were previously living in houses, and their fur is a large range of color, from white to dark brown, and every shade in between. The mice now live outside in the tall, pale grass in the open space. The local predatory birds have noticed. Make a graph and explain what happened. I'm not going to make the graph, but we can talk about the graph. What graph would we choose for this, do you think?
Bar graph.
I would probably choose a bar graph that would have a before and after, with the numbers before and the numbers after, and I would have the different colors that were in there, like black before, black after, white before, white after. What did we notice? What were better suited to survive before and after?
They were all doing really well.
Yeah, there was no major difference before, so there was no selective advantage towards hair color prior. However, afterwards, the tan ones ended up being a lot more successful, where the black ones were really the least successful, right? Their numbers really made it so that they were easier to see. White was probably middle easy to see, and tan was the most fit to like avoid predation, right? So hopefully in your answer you put some combination of those ones with, I would say, a bar graph. Yeah, I would do a bar graph. The other thing that you could do is maybe, no, we would do 2 bar graphs, or 1 bar graph with 2 datas inside there. And if anyone wants, I'm not going to do that right now because I'm recording, but I can show you how to do that afterwards, or if you come to office hours. Why did Wallace explain that placental mammals are found west of the Wallace line and marsupial mammals are found east? So you guys should have had this earlier in your note. Someone have an answer for this? Hannah.
Okay, so when the animals were moving over to the Malay archipelago, there was like, I guess, a border of like water that they could pass. So those who were on the west were placental, and those on the east were marsupial, but they were never able to coexist because of that barrier of water.
There was a barrier, right, that separated the archipelago. Between the east and west. So you were saying, so placental mammals had a common ancestor that was west of the Wallace line, and marsupial mammals was east. The barrier, right? The barrier kept these 2 lines separate, so they evolved differently, right? I think that's okay. Was there anything that I missed from that right there? So basically this barrier that was the ocean separated these 2 land things. So prior to that, prior to splitting up into these 2, there was a common ancestor also. That's an important thing, right? There was a common ancestor that was shared by both of them. Then the archipelago set up, which separated them. And then from that point, they're both mammals, except one ended up being placental and the other one ended up being marsupial. So everything on one side of it had one common ancestor, which was the common ancestor of placental mammals, and the other one had a common ancestor that was a common ancestor for marsupial. So if you guys are writing, and you can, this is okay, but this is not imperfect, right? Identify the contributions of these ones. There was a Hold on. There was a an answer that we had for this, right? That we did earlier. So, it's one that's taken from. So I was gonna try just copying and pasting it into there, but I guess there was a. All right, so this right here is good for the answer here. Each of them. Lyell, natural laws were consistent over time, which dealt with gradualism. That means that things happen and change slowly over time. Wallace, he believed in natural selection after visiting the Malay archipelago visit. And so he helped to basically come up with the same ideas as Darwin, except from a separate area, with the archipelago being the placental ones. Malthus, this was the economist. He believed that human population growth and food need would control it, and that there are checks and balances. So there's always going to be a limit to what you can have in terms of what's energy available, and that competition, that idea for competition, was huge for the idea of natural selection. Right? It's an economic idea that only right competition, only some will survive. You have Lamarck, who believed that you could acquire traits. Now, he was wrong because he thought it could happen over a lifetime, that you could make your neck longer, where we know that you basically, where do you get your traits?
Parents.
You inherit them, right? So yeah, from your parents. Describe how natural selection drives evolution. Who wants to get us that one? Let's go, Alexis. All right, so I think I got what you're trying to say. Natural selection is the survival of the fittest, which means that organisms that survive are able to pass on their traits to their offspring. The population will change over time based on the fitness of the offspring, right? The fitter ones will survive and reproduce. In evolution, how do adaptations arise? Let's go, Rosa. Arise from what? So that is one place that adaptations good. Also, they can also come from survival of the fittest, right? So there's a couple ways, and also can come from sexual reproduction differences, right? So while you guys may share traits with your parents, you are not clones of your parents, and those combinations of traits from your parents can lead to some pretty important differences. And then, of course, I'm going to go ahead and add these ones on there. So not only can natural selection do that, but mutation, gene flow, and genetic drift are the other mechanisms that can lead to it, and it's probably a good idea that you understand that each of them, so you already got mutation, but gene flow and genetic drift are the other ones, which is incoming population and new genes. Genetic drift is random survival. All right, what did Ure show us? That precursors, I'm trying to get into the 15-minute precursors for life can form in ancient environment. That is not going to survive, and